Okay, hello everyone. My name is candra.diningrat, and in this video I'm going to show you how to create this simulation using NX Mechatronics Concept Designer. So maybe you have seen my demonstration on my LinkedIn post for this video, and this video explain or demonstrate that I have the simple simulation created with NX MCD. So this is just a simple logical behavior. So if the lower sensor detects some part, this green box will be, or green part will be transferred to the green conveyor. And if two sensor detect some part here, or I mean the large part detected, the large part, that part will be transferred to the brown conveyor. So I will show you how to create this step by step right from the start. uh, how to create this simulation using NX Mechatronics Concept Design. So this is my complete simulation, and I have another assembly with the same part. And in this assembly has no definition, or I mean has no stuff for an XMCD simulation. So this assembly has no logical or basic physics or anything else created in an XMCD. So now we have this assembly going that we are going to create this simulation with an XMCD. So let's get started. So, okay, the first thing that I need to do is create the rigid body. So I'm gonna create rigid body for these two parts. Let's add the name. For example, small product, green product. Okay, small, so small. Small, apply. And for the large product also, large. We can also create the user-defined mass properties to this rigid body, but in the simulation, I just want to create as it is, or using the automatic definitions. So I just use the default settings. I'm gonna click OK, and I click the play button. So those parts will be uh, falling down. And the next step, I need to create collision body for these two parts, because and I don't want to create highlight. I don't want to check this highlight on collision, because sometimes is really a little bit annoying seeing this pink box. So for the collision definition, we can also select another collision shape, or other collision, for example, sphere, cylinders, capsule, convex, multi-composite, or mesh. So in this case, I just want to select the box collision shape. So for simplifies my simulation, I just click OK. And then if I click the play button again, it's still falling down. And to prevent that happen, I need to create some collision body to this conveyor. So I need to create collision body to this conveyor. And I can also create the collision body together with the transverse surface. So I want to define all those two definitions in one command using this transverse surface. So I'm gonna select this surface to define my conveyor simulation with this vector, this vector with this speed, with this speed, and I also want to create the collision body. So if I click play against it, define my conveyor simulation, including the collision body. Okay, and then I just want to create another surface transfer surface definition for this conveyor with this vector, and also for this conveyor with this vector. Okay, and then I need to create some rigid body to this robot. So this robot was downloaded from the ABB website, so you can search on it. You can search on the ABB website to download this part. So, and then we are going to define the rigid body to this robot. So, for example, I want to create this rigid body, this one, and also for the um, suction. Yeah, for this suction. Okay, for this case, yeah, so for ideal simulation, we need to define for this character. For example, I need to define four rigid bodies, but in this simulation, I want to simplify, so I don't want to use this axis. So I don't want to create. I don't want to create some joint here. So I just want to delete this definition, and I want to add this rigid body definition. So in this rigid body definition, I just want to create two body. So this rigid body has two body together in one rigid body definition. So just to simplify my simulation. Okay, if I click again, my play button is still falling down. So I need to define now the basic join. For example, I need to create a fixed join for this rigid body, and also I need to define the hinge join for this attachment respective to this base, and also I want to select this vector. Okay, and I also need to create the sliding joint to this suction cup, to this suction cup holder, or the last arm robot, for this attachment respective to this base with this vector. Just simply click OK, and if I click play button, it's still falling down for this sliding join because I haven't created some lock definition, which is need to create by using this position control or speed control. So in this case, I want to use position control for this join. So this join with I don't need to create. I don't need to define any other parameters. So I just simply click apply, and I need to create the position control for this his join also. So sorry, for this hinge joint I need to create some angular path option. So in this case I need to select the follow surface path because I need to use the clockwise rotation, and also I need to use the counterclockwise rotation. So I need both ways, I need both directions. So I simply select this follow shortest path because I need both direction. So not just one direction, counterclockwise or just clockwise. Okay, just simply click OK in this position control, and now what else? Okay, I need also to create some gripper definition in this rigid body. And for creating the gripper definition in or simulation in MCD, there are many ways that we can use, but the simplest way or the right way is by using this dedicated gripper function or custom behavior. So I need so I will use this function. So in this command, gripper command, I can choose the finger gripper or suction cup. So for example, I want to use the suction cup. I just want to select the base body, and also I need to define the detection area. So the detection area has the function for detect the part that will be attached to this base body, to this gripper. So it will activate the gripper function if this area is detected. So something like that, yeah. Okay, I just want to define this detection area. For example, I want to use this center with down direction. Simply click OK, and now we can adjust the dimension for this detection area. For example, I just want to define the diameter slightly larger, or simply like this. Okay, slightly larger, and for the detection area also I just need something like this, yeah, with this dimension. I just give and we also need to create the action time or the duration for this gripper. So for example, I just specify the 0.5 second for the action time for this gripper. So I just simply click OK, and we need also to define the collision sensor now. So I just need to create collision sensor using this command. Yeah, this collision sensor command. So I want to select this rigid body. No, this body, this solid body. I mean, with the collision shape is cylinder. Is yeah. We can also select the collision shape, but for the right representation for this case is cylinder. Also, we can also use the line to simplifying, but just I want to use the cylinder. Simply click apply, and also I create another collision sensor and click OK. Okay, now we are ready to create some operation, I think. Okay, let's try to create some operations. So the first thing that we need to create in the operation. So if you have you don't have this sequence editor, you just click this sequence editor and click undock tab, and it would be applying a tab like this. You just uh, attach to this area, so it will be attached to this bottom of your window. Okay, let's add some operation. So the first thing, we need to create this conditional operation for the for example, for the small parts first. Yeah, for the small part condition. So for example, I need to create operation here if this sensor, this sensor, you can also select the actuator or sensor in this physics navigator. You can also select in this window. So if this sensor is triggered or true, value is true, let's add some name here. Mm, small part detected. Okay, if this sensor is true, and we can also specify the duration. For example, I want to specify the 0.5 second. Simply click OK, and after this sensor is detected, I want to stop this conveyor. So I just need to create another operation here. I want to stop this transport surface or this conveyor. To stop this conveyor, we just need to select this physics object, or we can select in this physics navigator, and we want to deactivate this function. Yeah, I need to turn off this conveyor with this delay, with zero delay. Okay, let's add some name now. Turn off conveyor. And to define the if then condition, we just need to connect this the select drag to this operation. Okay, let's try our simple behavior or simple function now. And yes, it is stopped, but the delay is too much longer. So I need to shorten this duration. For example, maybe 0.2 second, and let's try it again. So with this MCD, we can try our parameters virtually like this. So we can specify our specific parameter or definition in the right way. So let's try it again. Okay, it's still, I think it's still too much, slightly too much longer for the delay. So for example, I need to specify it to change it again, or shorten the duration again to 0.150. Okay, let's try it again. Okay, it looks good. Okay, the first parameter is defined properly, and we are ready to add more operation now. So for next operation, for example, I need to move this rigid body down. So just to move down this rigid body, so I just need to create another operation for this physics object, or for this position control. with some speed. I just want to specify the speed and the position from 0 to some position, yeah, position. And to define the right position, we can choose the measure method here. For example, I want to measure this surface, or I think I misselect. Okay, this surface to our product surface with this vector, respective to this vector, for example. So we have now the right dimension to our moving position. Okay, simply click OK. When now we have this dimension, and I just want to round up this value to 0.76 millimeters, for example. And we need also to specify the name. For example, suction move suction down. Okay, and we can also zoom out in this window, I mean this in this sequence editor, and connect it again. Okay, after this we need to activate our gripper. Yeah, after this suction is moving down, we need to activate our gripper. To activate our gripper, we just simply create another operation here, and we just need to select our gripper and set the runtime parameter. For the grip parameter, we select the true value, and the release is false. Okay, and for example, I add the name for gripper on. Simply click OK, and again connect the operation together. Okay, I need to add more operation again. I need to move up now this rigid body, and I just need to copy this operation and paste to this operation here. And I just modify the position to 0 again, move suction up, define move suction up for the name, and connect this operation. Okay, let's try our operation now. Okay, okay, it's good. It's okay. After this, the suction is moving up. I need to turn on back my conveyor. So for example, I need to add more operation again. Okay, before I doing that, I just leave the turn on operation for the next activity. Uh, let's add more operation for this robot first. So for example, I need to move this, I need to rotate this robot. I just need to create another operation for this position with this, for example, 200 the speed to 90-degree position. For example, 100 first, and add the name, for example, rotate robot 2. Okay. And at the same time, the robot rotate to 90-degree position. I want to activate again my conveyor, so I need to turn on back my conveyor, active this parameter, back to true condition, and give the name turn on conveyor. Okay, sorry, I made a mistake. So it should be after this, after the suction up. Yeah, after the suction up, conveyor will turn back on. Okay, let's try it. Okay, stop the conveyor suction, and yes, the conveyor is turned back on again. Okay, we can leave the second part, the large part, for the next operation. Just leave as is for now. And we just need to complete the first product operation first, yeah. And for the second operation, for this product, the second product operation, we just need to copy it. Okay. Okay, after the robot is rotating to 90-degree position, I need to move down my suction again. So I just need to copy this operation and paste to this one and connect this rotate robot to 90 degree to this move suction down operation. Okay, after the suction is moving down, I need to uh, release my gripper. But for this position, I need to adjust the position a little bit. Okay, and after the suction is moving down in this conveyor, yeah, in this green conveyor, I need to release my gripper now. So I just need to copy my operation for the gripper here, paste in this operation, and change the value, the runtime parameter value for the grip is false and the release is true now. Or release the gripper now. Gripper off. And simply connect again these two operations together. And after the gripper is released, we need to move up again our suction. So I just need to copy this operation to this below this operation, and simply connect this operation together again. And now we need to rotate our robot back to 0-degree position. So I just copy this operation and rename this one. Rename this definition, this operation. I mean, and set the position to 0 again. Okay, let's connect these two operations together. So I think we our first our operation our operation for the first product is ready. Let's try it on. Okay, that's it. Good. Okay, for the second product, for the second product, we just need to copy all these products together and change some parameters a little bit, and we can go or we can finish our activity. So before I doing that, I need to create some group first. I need to create a group. For example, okay, this is my group. I need to change the name. For example, is the first product for small product. So, and then I want to move all this operation to this small product group, and now I want to copy this group to this root operation. Now, and now we have another group now, and I want to change the name to the large product. And now for the large product, we need to change some parameters. So the first one that we need to change is the conditional sensor to start this operation. So firstly, I need to change the name first, and now we need to add more condition here. So the way to do it is to add group now, add group, and I want to select this second sensor. So the condition is if two sensor is triggered. So it means the large product come through this area, and then the operation, all the sequence of the all the sequence for the large product operation will run. Okay, so this is the condition, and I need to change the this one, yeah, move section down. So because the uh, this part is larger than is taller than this product, so I need to change the position a little bit here. So I need to create a measure position again from this surface. Okay, sorry, from this surface to this surface. So I have now the measurement position in this number. Yeah. Okay, I just run up to 146 millimeters. Okay, and also for this one, yeah, 144. I need some clearance for move down this product to the brown conveyor. Just leave the 2 millimeter gap for the smooth operation. Okay, and then we need to change this rotation also. Yeah, from the 90 degree to 170 degree. And because we have created this position control with the constraint of follow the surface path option. Now so we can move these robots, or these robots, I mean this rigid body, for the clockwise operation or for the counterclockwise operation. And now I think we are ready. Our program is ready now, and the another step that we need to create is the uh, object source definition. So I need to change, or I need to specify that my first product here, it will continuously uh, continuously show, or continuously appear with the 10-second time interval. And for the second product also, with time interval for 10 seconds, for example, with start offset with of 5 seconds. So it just I need just some create I just need to create some delay between this uh, product. Yeah. Okay, let's try our program. So this for the first product, and after 5 seconds the second product will show up. It's showing up. Okay, okay, that is for the first product, and this one for the second product. Okay, it's good. First product again. Okay, you can see that sometimes the first product is uh, uh, it's not detected. Yeah, it's just detected, or you can see that the delay here, or some delay is not uh, defined properly, and you can see the first product was falling down again. And this is happened because I think our robot is too slow. Yeah, this robot is too slow to come back to the this home position or zero position. So now I need to change uh, my robot speed. For example, I think, for example, I need to change the speed twice for this one and also for this one, and also for the large product of this, for the small pro, and also for the large product operation. uh, okay, I mean I think this one for is 270 degree, and I will double my speed, and also for this operation, robot operation. Okay, let's try it again. I think it's gonna work now. Okay, that's good. we need to wait for some operation iteration. Yeah, we need to wait for some iteration, I think. Okay, you can see there is no more false operation now, and I think our product is clearly defined or properly defined. Okay, that's all for me. I hope this video will help you. Maybe. Um, Thanks for watching. See you in the next video.